What if the next gold rush doesn't happen on Earth? What if the most valuable mines in human history are not buried beneath continents, but drifting silently through space? Right now, as you watch this video, millions of asteroids are orbiting the sun. Each one carrying metals worth more than entire nations, water that could fuel deep space expansion, and resources that could redefine power, wealth, and survival in the 21st century. Governments are watching, private companies are racing, and quietly, a new economy is forming beyond Earth's atmosphere. This is not science fiction anymore. This is the beginning of off-world economics, a race where the winners may control the future of civilization, and the losers may never catch up. But asteroid mining is not just about technology or profit. It raises uncomfortable questions about ownership, inequality, environmental collapse, and whether humanity is ready to export its economic systems into the cosmos. So before the first drill ever touches an asteroid, we need to ask something far more important. Who gets to claim space, and at what cost? Stay with me, because what begins as a story about mining quickly becomes a story about power, scarcity, and the next chapter of human history. In this video, you will discover how asteroid mining works and why certain asteroids are more valuable than anything ever mined on Earth. You will learn which resources drive the off-world economy, from rare metals to water and fuel, and why space agencies and private corporations are willing to invest billions before a single profit is made. We will explore the economic logic behind asteroid mining, including launch costs, market disruption, and the possibility of collapsing entire industries back on Earth. You will see how space law struggles to keep up with technological ambition, and why the question of who owns space remains dangerously unresolved. And finally, we will examine whether asteroid mining represents humanity's greatest opportunity, or the moment we repeat Earth's economic mistakes on a cosmic scale. Welcome to Where the Light Ends, a place where space grows silent, light fades, and the universe begins to reveal its darkest secrets. To understand why asteroid mining has suddenly become one of the most serious economic conversations of our time, we need to start with a simple truth that often gets overlooked. Asteroids are not rare. They are not distant anomalies. They are everywhere. Between Mars and Jupiter lies the asteroid belt, a vast region filled with millions of rocky bodies left over from the formation of the solar system. Beyond that belt, near-Earth asteroids pass quietly through our cosmic neighborhood every single day. Some of them come closer to Earth than the Moon. Some are small, others stretch for kilometers, and many of them contain concentrations of valuable materials that do not exist on Earth in such purity or abundance. These objects are not random rocks. They are time capsules, frozen remnants of the early solar system, untouched by geological recycling, erosion, or plate tectonics. On Earth, metals like platinum, iridium, and palladium are incredibly rare near the surface because gravity pulled them deep into the planet's core billions of years ago. But asteroids never formed large planetary bodies. Their heavy elements stayed near the surface, locked inside relatively accessible structures. This is why a single metallic asteroid, only a few hundred meters wide, can theoretically contain more platinum group metals than have ever been mined in human history. On paper, the value of some asteroids reaches into the trillions of dollars. But this is where the story becomes more complicated, because value in space does not work the same way it does on Earth. Not all asteroids are equal. Scientists generally classify them into three major types. C-type asteroids are carbon-rich and often contain water bound within minerals. These are not flashy, but they may be the most important of all, because water in space means life support, oxygen, and rocket fuel. S-type asteroids are composed primarily of silicate materials and metals like iron and nickel. And then there are M-type asteroids, the rare metallic giants believed to be remnants of planetary cores, packed with dense concentrations of valuable metals. For space agencies and private companies, the appeal is not just about precious metals. In fact, bringing large amounts of platinum back to Earth could crash markets and destroy its own profitability. The real economic revolution lies elsewhere. Water extracted from asteroids can be split into hydrogen and oxygen, creating rocket propellant. This would allow spacecraft to refuel in space instead of carrying all their fuel from Earth, dramatically reducing launch costs and enabling deep space missions that are currently impossible. This shifts the entire economic logic of space exploration. Instead of space being a place we visit briefly at enormous expense, it becomes a place where infrastructure can exist permanently. Asteroids become gas stations, supply depots, and construction yards floating in orbit. The economics are no longer about extraction alone, but about location. And location in space economics is everything. Near-Earth asteroids are particularly attractive because they require less energy to reach than the surface of the Moon. Some of them have orbits that make rendezvous easier than landing on another planetary body. In economic terms, they are low-hanging fruit. The energy cost to access them is lower, the mission windows are frequent, and the return on investment becomes more plausible with each advancement in propulsion and robotics. This is why asteroid mining has moved out of the realm of science fiction and into serious planning documents. Space agencies like NASA and JAXA have already conducted missions that touched, sampled, and returned material from asteroids. These missions were not about profit, but about proof. Proof that autonomous spacecraft can navigate, land, extract material, and survive in microgravity environments. Once that proof exists, the question stops being, can we do this? And becomes, who will do it first? This is where economics collides with geopolitics. In traditional history, control over resources has always translated into power. Gold fueled empires. Oil reshaped the 20th century. Rare earth elements now sit at the center of global supply chain tensions. Space resources follow the same pattern, but with one critical difference: there are no established rules. International space law, built on treaties written during the Cold War, was designed to prevent nuclear weapons in orbit, not to regulate trillion-dollar mining operations. The Outer Space Treaty declares that no nation can claim sovereignty over celestial bodies, but it remains vague about resource extraction. Some countries interpret this as permission to mine as long as they do not claim territory. Others argue that extraction itself implies ownership. This legal ambiguity creates a dangerous incentive structure. The first actors to establish operational capacity in space may effectively write the rules through action rather than agreement. Once infrastructure exists, once investments are sunk, laws tend to adapt to reality rather than the other way around. And history shows us what happens when economic expansion outpaces regulation. Asteroid mining is often marketed as a clean alternative to Earth-based extraction. No forests destroyed, no oceans polluted, no communities displaced. But this framing ignores a deeper issue. If off-world resources become the backbone of advanced economies, who controls access to them? Will space wealth concentrate in the hands of a few corporations and nations, or will it be treated as a shared inheritance of humanity? Even more unsettling is the possibility that space resources delay necessary change on Earth. Instead of transitioning away from unsustainable consumption, asteroid mining could allow wealthy societies to postpone environmental responsibility by outsourcing extraction beyond the planet. The damage would not disappear. It would simply move out of sight. At the same time, the benefits are real. Off-world resources could enable space habitats, long-term missions to Mars, and scientific exploration on a scale we have never seen. They could reduce the need for destructive mining practices on Earth. They could redefine scarcity itself. This tension between opportunity and repetition, between expansion and exploitation, sits at the heart of space economics. Asteroid mining is not just a technological challenge. It is a mirror. It reflects how humanity approaches power, wealth, and the future. The rocks floating above us are silent, indifferent witnesses. What matters is not what they contain, but what we choose to become when we reach them. And this is only the beginning. The transition from scientific curiosity to economic ambition in space did not happen overnight. For decades, asteroid missions were framed as purely exploratory, exercises in data collection, planetary defense, and understanding the origins of the solar system. But beneath that scientific language, something else was happening. Every successful mission quietly reduced the uncertainty that once made asteroid mining impossible. When spacecraft like Japan's Hayabusa and NASA's OSIRIS-REx touched an asteroid, collected material, and returned it safely to Earth, they demonstrated more than technical precision. They proved reliability. In economic terms, reliability is everything. Investors do not fund ideas. They fund systems that repeat success. These missions showed that spacecraft can autonomously navigate irregular gravity fields, anchor themselves to surfaces that barely exist, and manipulate material in environments where traditional mining concepts break down completely. There is no up or down on an asteroid, no weight to hold equipment in place. Every action risks pushing the spacecraft away from its target. Solving these problems required entirely new approaches to engineering, robotics, and control systems. Once those barriers began to fall, the conversation changed. Private companies entered the picture, not because the technology was perfect, but because it no longer seemed impossible. Startups and aerospace firms began modeling extraction systems, refining processing techniques, and simulating off-world supply chains. The idea was not to mine everything at once, but to start small, learn fast, and scale over time. This is where asteroid mining separates itself from traditional resource extraction. On Earth, mining benefits from centuries of accumulated infrastructure and human labor. In space, everything must be autonomous, lightweight, and brutally efficient. There is no room for excess. Every gram launched from Earth costs money. Every system must justify its existence. As a result, space economics favors simplicity. Early asteroid mining concepts focus on extracting a single resource at first: water. Not metals, not rare elements. Water. Water is heavy, expensive to launch, and essential for every aspect of space operations. It supports human life, radiation shielding, thermal regulation, and fuel production. In economic terms, water is a universal input. Any system that can reliably extract water in space immediately becomes valuable, even if it never returns a single kilogram to Earth. This reframes what profit means. Instead of selling materials on Earth, early asteroid mining operations would sell services in space: fuel depots in orbit, life support supplies for missions, construction material for space stations. The customer is not the consumer market, but other space actors. This creates the first true space economy, one that exists largely independent of Earth-based demand. However, this vision depends on a fragile assumption that launch costs continue to fall. Over the past 2 decades, the cost of sending payloads into orbit has dropped dramatically, driven by reusable rockets and commercial competition. This trend has made previously absurd ideas suddenly plausible. But economics is not destiny. If launch costs plateau or increase, many asteroid mining models collapse instantly. This is why timing matters so much. Companies are racing not because the resources will disappear, but because the economic window may close. The first wave of space infrastructure must be built while access remains relatively affordable. Miss that window, and the barrier to entry rises again. There is also the question of scale. A single successful mining operation would not immediately transform the global economy, but a network of them could. Once multiple asteroids are being exploited, once refueling stations exist, once construction moves off-world, the entire cost structure of space changes permanently. At that point, the advantage compounds. Early movers gain experience, data, and logistical dominance. Late entrants face higher costs and fewer opportunities. This is the same pattern seen in every historical resource frontier, from oceans to continents to orbit. Yet space introduces a new variable. Distance does not protect you. On Earth, geography limits competition. In space, orbits intersect, access overlaps. The same asteroid can be reachable by multiple actors over time. Control is not about possession, but about presence. This leads to a subtle but critical shift in strategy. Instead of claiming territory, future space powers may focus on controlling infrastructure. Who owns the refueling stations? Who controls the processing facilities? Who sets the technical standards others must rely on? Power in space may not look like flags planted on rocks. It may look like contracts, compatibility, and access. And once again, law struggles to keep up. Some nations have already passed domestic legislation granting their companies rights over resources they extract in space. These laws do not claim sovereignty over asteroids themselves, but they effectively legitimize private ownership of space resources. Critics argue that this undermines the spirit of international cooperation. Supporters argue that without legal certainty, no one will invest at all. This debate is not abstract. It will shape who participates in the space economy and who is left behind. Developing nations, already disadvantaged in technological capacity, may find themselves excluded from off-world wealth before they ever have a chance to engage. The promise of asteroid mining is often framed as abundance, but abundance does not automatically produce equality. Without deliberate governance, it can deepen divides instead. And there is another risk rarely discussed: strategic denial. If space infrastructure becomes critical to global systems, then disabling or monopolizing it becomes a powerful lever. Control over off-world resources could translate into geopolitical influence back on Earth. In this sense, asteroid mining is not just about economics, it is about security. As humanity pushes outward, it carries its old instincts with it: competition, control, accumulation. The question is whether space will amplify these instincts or force us to evolve beyond them. The asteroids themselves do not care. They have waited billions of years. They will continue to wait. What matters is how we choose to approach them, not as conquerors chasing wealth, but as a species deciding what kind of future it wants to build beyond its home planet. Scarcity has always shaped human behavior. On Earth, scarcity is defined by geography, politics, and environmental limits. In space, scarcity takes on a different meaning, one driven by energy, access, and time. Asteroids may contain immense resources, but abundance does not exist until those resources can be reached, processed, and used. This is where the true economics of asteroid mining emerges. Every mission begins with a cost that has nothing to do with the value of the asteroid itself: energy. Launching mass out of Earth's gravity well remains the single most expensive step in any space operation. Even with reusable rockets, every kilogram sent into orbit carries an economic penalty. This forces space economics to prioritize efficiency above all else. On Earth, miners move toward ore. In space, systems must move toward minimal energy paths. This is why orbital mechanics matter as much as market prices. An asteroid with lower resource density, but easier access, may be more valuable than a richer asteroid that requires significantly more energy to reach. This concept, delta V, becomes the currency of space. Delta V measures the change in velocity required to perform maneuvers in space. Lower delta V means lower fuel costs, simpler missions, and higher probability of success. In this context, asteroids are not valued by what they contain alone, but by how cheaply they can be reached and exploited. This transforms how value is calculated. A trillion-dollar asteroid that costs hundreds of billions to access is not an opportunity. It is a liability. The real targets are modest, unglamorous bodies that sit in energetically convenient orbits. Once extraction begins, another challenge appears: processing. Raw material is useless unless it can be refined. In microgravity, traditional industrial processes fail. Heat behaves differently. Fluids do not settle. Dust becomes a hazard. Every processing method must be reimagined from first principles. This is why early asteroid mining is likely to involve minimal processing. Instead of refining metals into finished products, Companies may focus on producing basic outputs, water, gas, or simple structural materials that can be used immediately in space. Complexity will come later, once infrastructure matures. This incremental approach mirrors the early days of terrestrial industrialization. Railroads came before skyscrapers, steam engines before electricity grids. In space, fuel depots and material caches will come before orbital factories and megastructures. And just like on Earth, the first infrastructure builders gain disproportionate influence. Control over supply points creates dependency. If spacecraft must refuel at specific locations, those locations become strategic. Pricing power emerges. Access can be restricted. Markets form around bottlenecks rather than abundance. This challenges the popular narrative that space will naturally democratize resources. Without careful governance, it may do the opposite. Scarcity shifts from material to access. Those who control logistics control outcomes. There is also the issue of time horizons. Asteroid mining does not produce quick returns. Initial investments are massive, and early profits are uncertain. This favors actors with patience, governments, large corporations, and entities capable of absorbing losses for years or decades. Smaller players may innovate, but scaling requires capital. This creates consolidation pressure from the very beginning. Over time, the space economy may resemble terrestrial industries where a handful of dominant players control critical infrastructure. At the same time, space introduces a countervailing force, risk. Space is unforgiving. Systems fail. Missions are lost. A single error can destroy years of investment. This uncertainty limits monopolistic behavior by increasing the cost of overextension. In economic terms, asteroid mining sits at the intersection of high fixed costs and extreme uncertainty. This makes cooperation attractive, even among competitors. Shared standards, joint missions, data exchange. These mechanisms reduce risk while preserving competitive advantage. But cooperation is fragile. As stakes rise, incentives shift. What begins as collaboration can become exclusion. Technical standards can be weaponized. Access protocols can become barriers. The line between efficiency and control blurs. This brings us back to the core question of space economics. Is off-world expansion a continuation of Earth's economic systems, or an opportunity to design something new? Asteroids offer more than resources. They offer a test, a chance to decide whether humanity exports extraction-first thinking into the cosmos or learns from its own history before repeating it on a larger scale. The rocks drifting through space are neutral. They impose no rules, no ethics, no boundaries. Those will come from us. And as we move closer to turning asteroids into assets, one truth becomes impossible to ignore. The future of space economics will not be decided by technology alone, but by the values embedded into the systems we build. This is why asteroid mining matters, not because of what we might gain, but because of what it reveals about who we are becoming as a spacefaring species. Every major economic transformation in history begins the same way, quietly, experimentally, and underestimated. By the time the world realizes what is happening, the rules are already being written by those who arrived first. Asteroid mining is following that exact pattern. At first glance, the idea appears futuristic, distant, speculative, even unrealistic. But behind closed doors, governments and corporations are treating off-world resources not as a possibility, but as an inevitability. The question is no longer if space will be mined, but who will control the process when it becomes viable. In the early days of space exploration, national space agencies dominated the field. Missions were symbolic, scientific, and political. Space was a stage for prestige, not profit. But that era is ending. Today, private companies sit at the center of space innovation, driven not by ideology but by economics. This shift fundamentally changes the nature of competition. Corporations approach space differently than governments. They optimize for cost, scalability, and return on investment. They accept risk in exchange for first-mover advantage, and unlike states, they are not constrained by election cycles or public opinion in the same way. This gives them agility and power. Asteroid mining fits perfectly into this mindset. It is capital-intensive, high-risk, and potentially transformative. Exactly the kind of frontier where private actors thrive before regulation solidifies. But corporations do not operate in a vacuum. They are deeply intertwined with national interests. Launch facilities, legal frameworks, military protection, and diplomatic support still come from states. This creates a hybrid model of space power, where private ambition and national strategy overlap. In this model, space resources become instruments of influence. A nation that enables its companies to mine asteroids gains more than economic benefits. It gains strategic leverage. Access to fuel, materials, and infrastructure in space translates into operational freedom. Satellites last longer. Missions reach farther. Military and civilian capabilities expand simultaneously. This is why asteroid mining has attracted the attention of major powers. Some countries view off-world resources as a way to reduce dependence on fragile Earth-based supply chains. Rare metals critical to electronics, energy systems, and defense technologies are often concentrated in politically unstable regions on Earth. Space offers diversification, not by replacing Earth, but by supplementing it. Others see space as a domain where early dominance can lock in long-term advantage. Once infrastructure exists, catching up becomes exponentially harder. The cost of entry rises. The learning curve steepens. Early actors define standards and norms that others must follow. This is not colonization in the traditional sense, but it is expansion. The language surrounding asteroid mining often avoids these implications. It speaks of innovation, sustainability, and shared progress. But economic history tells us that resource frontiers rarely remain neutral for long. They attract competition, conflict, and consolidation. And yet space complicates everything. Unlike Earth, there are no indigenous populations to displace, no borders to cross, no sovereign territory to annex. This creates the illusion of a clean slate, a place where past mistakes do not apply. But the absence of people does not eliminate power dynamics. It simply changes their form. Control in space is subtle. It emerges through access to launch capabilities, orbital positions, data, and timing. A company that can reach an asteroid cheaply and reliably holds an advantage that no legal framework can easily neutralize. This raises a fundamental question: who is space for? International treaties describe space as the province of all humankind, but this phrase lacks enforcement mechanisms. In practice, access to space is already unequal. Only a handful of nations and corporations possess the technology, capital, and experience required to operate beyond Earth orbit. Asteroid mining threatens to deepen this divide. If off-world resources become central to economic growth, those without access risk permanent marginalization. The gap between space-capable and space-dependent societies could grow faster than any inequality seen before. At the same time, supporters argue that asteroid mining could lower barriers over time. As infrastructure expands and costs fall, access may widen. Space, they claim, could follow the same trajectory as computing or telecommunications, initially exclusive, eventually ubiquitous. Both outcomes are possible, and that uncertainty defines the current moment. What is clear is that asteroid mining is not just a technical endeavor. It is a political and economic experiment unfolding in real time. Decisions made today about law, ownership, cooperation, and competition will shape the structure of the space economy for generations. And unlike previous frontiers, there is no higher authority to intervene once the system takes shape. This is why the race is accelerating. Every successful mission reduces risk. Every legal precedent strengthens claims. Every investment signals commitment. And as momentum builds, hesitation becomes costly. History rewards those who move first, but it also punishes those who move without foresight. As humanity stands at the edge of this new gold rush, the stakes extend far beyond profit. What is being mined is not just rock and metal, but the future architecture of power beyond Earth. Every economic system rests on a foundation of rules: property rights, contracts, enforcement. Without them, markets collapse into uncertainty. On Earth, these systems evolved over centuries, often through conflict. In space, humanity is attempting to build an economy before it has built a legal framework to support it. This is the central tension of asteroid mining. International space law is anchored in treaties written during the mid-20th century, at a time when space activity was limited to a few government missions. These agreements were designed to prevent territorial claims and military escalation, not to regulate commercial extraction of resources worth trillions of dollars. The most important of these agreements declares that outer space is not subject to national appropriation. No country can claim ownership over celestial bodies. On paper, this sounds clear. In practice, it leaves a massive gap. The treaties say little about what happens once resources are removed. If no one can own an asteroid, can someone own what is extracted from it? Some interpret this as legal permission. Others see it as a loophole that undermines the spirit of shared access. Several nations have already acted on their own interpretations. Domestic laws have been passed, granting companies the right to own and sell resources they extract in space. These laws stop short of claiming sovereignty, but they create a de facto property regime. This approach prioritizes economic certainty over international consensus. Supporters argue that without clear ownership rights, investment will never materialize. No company will spend billions on infrastructure if the legal status of its output is ambiguous. From this perspective, unilateral action is seen as pragmatic. Critics warn that this sets a dangerous precedent. If each nation defines its own rules, space becomes fragmented. Competing legal regimes overlap. Disputes become inevitable. And in space, disputes are harder to resolve. There is no global authority capable of enforcing rulings beyond Earth orbit. Arbitration mechanisms rely on voluntary compliance. If a conflict arises over access to an asteroid, refueling station, or processing facility, there are few peaceful tools available to resolve it. This raises uncomfortable questions about security. Space infrastructure is fragile. Satellites, depots, and mining systems are vulnerable to interference. Even non-destructive actions, blocking access, altering orbits, disrupting communications, can have severe economic consequences. As off-world assets grow in value, they become targets. This does not necessarily mean open warfare, but it does mean strategic competition. Denial of access, coercive signaling, and economic pressure could all play roles. The line between civilian and military activity in space is already blurred, and asteroid mining may blur it further. This is why some analysts view space resources through a geopolitical lens rather than a purely economic one. Control over fuel and materials in orbit could translate into leverage over satellite networks, navigation systems, and even terrestrial infrastructure that depends on space-based services. In this sense, asteroid mining extends power dynamics beyond Earth rather than escaping them. Yet conflict is not inevitable. There is an alternative path, one based on cooperation, shared standards, and multilateral governance. Joint ventures could spread risk and benefit. International frameworks could establish rules for access, safety, and environmental protection in space. But cooperation requires trust, and trust is difficult to build when the stakes are high and the future uncertain. Some argue that the first true space economy will emerge not from idealism, but from necessity. As missions become more complex, no single actor will be able to operate alone. Shared infrastructure may become the only viable option. Others are less optimistic. They point to Earth's history, where resource competition repeatedly led to conflict despite opportunities for cooperation. Space, they argue, will be no different. The truth likely lies somewhere in between. Early stages may involve collaboration, driven by cost and technical constraints, Over time, as systems stabilize and profits grow, competition may intensify. What matters is how early norms are set. Once patterns of behavior become established, they are difficult to change. If the early space economy normalizes exclusion and unilateral control, those values may persist for decades. If it emphasizes openness and shared benefit, a different future becomes possible. Asteroid mining is not just about extracting resources. It is about defining rules in an environment where no natural rules exist. The silence of space does not mean neutrality, it means absence of guidance. What fills that silence will be decided by human choices driven by economics, law, and power. And those choices are being made right now. Every time humanity has discovered a new frontier, it has told itself the same story. This time will be different. New lands were framed as opportunities for progress, prosperity, and shared growth. Yet history reveals a more uncomfortable truth. Expansion often benefits a few while excluding many. Asteroid mining forces us to confront this pattern once again, but on a cosmic scale. The absence of indigenous populations in space makes ethical questions easier to ignore. There are no communities to displace, no ecosystems to visibly destroy, no borders to violate. At first glance, space appears morally empty, but ethics do not depend on the presence of victims alone. They depend on how power is distributed and who gets to decide. The central ethical question of asteroid mining is not whether humanity has the right to extract resources from space. It is whether all of humanity will benefit from that extraction. Access to space is already unequal. A small number of nations and corporations control launch systems, spacecraft design, mission planning, and data. These advantages compound over time. As off-world infrastructure grows, those without early access may find the barrier to entry permanently out of reach. This creates a form of economic gravity. Just as wealth on Earth attracts more wealth, space capability attracts more space capability. Early actors gain experience, capital, and political influence. Latecomers face higher costs and fewer options. In this scenario, asteroid mining does not eliminate scarcity. It reorganizes it around access rather than material. Some argue that this is simply how progress works. Innovations are always uneven at first, they say, and benefits eventually spread. Over time, costs fall, technologies diffuse, and access widens. Space, in this view, will follow the same trajectory as aviation, computing, or the internet. But there is a crucial difference. Unlike previous technologies, space infrastructure is not easily replicated. Orbital positions, transfer windows, and energy-efficient trajectories are finite. Early control over these elements can lock in advantage in ways that are difficult to reverse. This raises the risk of a permanently stratified space economy. The term space colonialism is often dismissed as exaggerated or ideological, yet it captures something real. Colonialism was not just about land. It was about control over resources, logistics, and systems of exchange. Asteroid mining has the potential to reproduce these dynamics without the visible violence that made them controversial on Earth. Instead of occupying territory, power in space may be exercised through contracts, standards, and dependency. Instead of armies, it may rely on infrastructure and denial of access. The result can still be exclusion, just with cleaner language. There is also the question of environmental ethics beyond Earth. Asteroids may appear inert, but large-scale manipulation of orbits carries risk. Even small changes in trajectory can have long-term consequences. Planetary defense experts already monitor asteroids to prevent collisions with Earth. Mining activities introduce new variables into an already complex system. While catastrophic outcomes are unlikely, they are not impossible. And unlike terrestrial environmental damage, mistakes in space may be irreversible. Supporters of asteroid mining counter that the ethical alternative is worse. Continued reliance on Earth-based extraction accelerates environmental collapse, climate change, and social conflict. If resources can be sourced from space instead, pressure on Earth may decrease. This argument has merit. but it assumes that off-world resources will be used to reduce harm rather than expand consumption. History suggests otherwise. Abundance often fuels growth, not restraint. Another ethical dimension is labor. Asteroid mining is often presented as fully automated, removing human risk. In reality, early operations may rely on human oversight, maintenance, and eventually presence. Who takes those risks? Who benefits from their success? Space labor could become the most extreme form of inequality, dangerous, isolated, and invisible to those who profit from it. At the same time, space offers something unprecedented, the chance to design systems from the ground up. There are no inherited institutions in orbit, no entrenched property regimes, no cultural assumptions carved into law. Everything is still negotiable. Asteroid mining could become the first truly global economic project, governed by shared principles rather than national interest. Or it could become the most exclusive economy ever created. The difference will not be decided by technology. It will be decided by choices made before profit becomes routine. Choices about governance, access, transparency, and responsibility. Space does not demand exploitation. It merely allows it. Whether asteroid mining becomes a story of shared progress or silent exclusion depends on whether humanity is willing to confront its own patterns before repeating them beyond Earth. And this is why the ethics of asteroid mining cannot be postponed. By the time extraction becomes normal, the moral framework will already be locked in. Silence in this case is not neutrality, it is consent. When historians look back on the moment humanity truly became a spacefaring civilization, they may not point to the first moon landing or the first Mars rover. They may point to something quieter, less dramatic, but far more transformative. The moment we stopped bringing everything from Earth. Asteroid mining represents that shift. For the first time in history, human expansion is no longer limited by what a single planet can provide. Space stops being a destination and becomes an environment, one that can sustain activity, growth, and permanence. This changes everything. A space economy built around asteroid resources does not resemble Earth's economy scaled upward. It operates under different constraints, different incentives, and different risks. Distance replaces geography. Energy replaces labor. Orbits replace borders. In this future, value is not determined by land ownership, but by position and timing. Who can reach which resource, how often, and at what cost becomes more important than who discovered it first. Markets respond not to scarcity of material, but to scarcity of access. As asteroid mining matures, its first visible impact will not be wealth flowing back to Earth, but capability expanding outward. Space stations grow larger and more complex. Missions last longer. Human presence becomes continuous rather than episodic. Mars, in particular, becomes more realistic. A sustained human presence on Mars is almost impossible without in-space resource utilization. Launching every kilogram of fuel, water, and construction material from Earth makes long-term settlement economically irrational. Asteroids change that equation. Water extracted from asteroids can support life and fuel transportation networks between Earth, the Moon, and Mars. Metals can be used for shielding and construction. Over time, supply chains form that exist almost entirely beyond Earth's gravity well. At that point, a new economic loop emerges. Space supports space. This is when asteroid mining stops being an industry and becomes infrastructure. And infrastructure reshapes behavior. Once off-world operations become reliable, the incentives for cooperation increase. Shared depots, common standards, interoperable systems. Space begins to resemble a network rather than a frontier. But this future is not guaranteed. Economic systems have inertia. Early design choices persist. If early space infrastructure is closed, proprietary, and exclusionary, it may remain so even as costs fall. Conversely, open systems can accelerate innovation but struggle to sustain investment. This tension mirrors debates already playing out on Earth. between public goods and private profit, between accessibility and control. In space, the stakes are higher because mistakes are harder to undo. There is also the question of dependency. As Earth-based systems integrate with space-based resources, vulnerability increases. Disruptions in space could cascade back to Earth, affecting communication, navigation, and economic stability. This creates a paradox. The more space supports Earth, the more Earth depends on space. Asteroid mining, once seen as optional, becomes critical. At that point, space economics intersects with planetary survival. Decisions about who controls off-world resources influence resilience in the face of climate change, resource depletion, and geopolitical instability. Some futurists argue that asteroid mining could enable a post-scarcity civilization, one where material constraints no longer dominate human conflict. In theory, the resources available in space dwarf those of Earth. But scarcity is not only material, it is institutional, political, psychological. Even in a universe filled with resources, competition can persist if access is uneven and trust is absent. Abundance does not automatically produce harmony. It amplifies existing systems. This is why asteroid mining is not a technological turning point alone. It is a civilizational one. It forces humanity to confront whether it will carry Earth's economic logic into space unchanged, or whether it will adapt to a larger context where survival depends on cooperation as much as competition. The future space economy will not emerge fully formed. It will be built mission by mission, contract by contract, failure by failure. Each decision will shape the next. And as the infrastructure grows, so does the question that quietly follows it. If humanity learns to live off-world, what does Earth become? A home? A heritage? Or eventually a dependency left behind? Asteroid mining does not answer these questions. It simply makes them unavoidable. Every vision of the future assumes success, functioning systems, stable growth, rational decision-making. But history rarely follows the clean path imagined by planners. Most economic transformations are shaped as much by failure as by achievement. Asteroid mining is no exception. The most immediate risk is not technological collapse, but economic miscalculation. Models that look viable on paper can unravel when exposed to real-world complexity. A slight increase in launch costs, a delayed mission, or an unexpected technical flaw can erase years of projected profit. In a field where upfront investment is massive and returns are distant, even small disruptions can have outsized consequences. There is also the danger of overconfidence. Early successes may create the illusion that space economics follows predictable trends. But space remains an extreme environment. Systems fail in ways that cannot be easily repaired. Redundancy is expensive. Human intervention is limited. If a critical piece of infrastructure fails, a refueling depot, a processing facility, a transport hub, entire supply chains could collapse. Unlike on Earth, there is no rapid replacement. Recovery could take years. This fragility introduces systemic risk. As space infrastructure becomes interconnected, failures propagate. A problem in one orbit affects operations in another. Delays compound. Costs rise. Confidence falls. Investment dries up. In this scenario, asteroid mining does not collapse spectacularly. It simply stalls. A stalled space economy would have consequences beyond space. Governments that invested heavily may face political backlash. Corporations may consolidate or exit the sector. Public trust in space expansion could erode, delaying progress for decades. There is also the risk of strategic misalignment. If asteroid mining becomes entangled with national security objectives, economic rationality may give way to political pressure. Projects may be funded for symbolic reasons rather than viability. Resources may be allocated inefficiently to demonstrate presence rather than generate value. History offers many examples of infrastructure built for prestige rather than necessity. Space is not immune to this temptation. Another risk lies in uneven development. If only a small group of actors benefits from off-world resources, resentment may grow. Space could become a symbol of exclusion rather than opportunity. This could fuel political movements demanding restriction, redistribution, or withdrawal. Such pressure might not stop asteroid mining, but it could distort it. Regulation could become reactionary rather than strategic. Long-term planning could give way to short-term appeasement. Environmental risks also persist, even beyond Earth. Large-scale manipulation of asteroids introduces uncertainties we do not fully understand. Changes in mass, rotation, or trajectory may have unintended consequences over long timescales. While safeguards can reduce risk, they cannot eliminate it. The more humanity alters space environments, the more responsibility it carries for outcomes that extend far beyond a single generation. But failure is not the only alternative to success. There is a third path: stagnation. Asteroid mining may remain perpetually almost viable. Technically impressive, politically supported, but economically marginal. In this world, space expansion continues, but slowly. Projects survive on subsidies. Breakthroughs are incremental. The transformative potential never fully materializes. This outcome is less dramatic, but perhaps more likely. And yet, even partial success changes the trajectory of civilization. Even limited off-world resource use reduces Earth's isolation. Even modest infrastructure shifts how humanity imagines its future. The greatest risk, then, may not be failure at all. It may be proceeding without reflection. If asteroid mining advances without ethical frameworks, without inclusive governance, and without long-term thinking, it could entrench inequalities and vulnerabilities on a scale never seen before. But if approached deliberately, it could offer something rare in human history: the chance to design an economic system before it becomes unavoidable. The future of asteroid mining will not be decided by a single mission or a single policy. It will emerge from cumulative choices, each one small, each one rational on its own, but together defining a direction. Whether that direction leads to resilience or fragility depends on what humanity chooses to value as it moves beyond Earth. Space does not promise salvation. It offers possibility. And possibility without wisdom has always been dangerous. There are moments in history that feel dramatic as they happen: revolutions, wars, discoveries announced to the world. And then there are moments that pass almost unnoticed, even though they quietly redefine everything that comes after. Asteroid mining may belong to the second category. There will be no single day when humanity officially becomes a multi-planetary economy, no ceremony marking the transition. Instead, it will happen gradually, through routine missions, incremental infrastructure, and decisions that seem technical rather than philosophical. One day, a spacecraft will refuel in orbit instead of returning to Earth. Another day, materials extracted from an asteroid will be used to build something never meant to touch a planet's surface. And eventually, it will feel normal. That normalization is the real turning point. When off-world resources become part of everyday planning, humanity's relationship with Earth changes. Earth stops being the sole provider and becomes one node in a larger system. Precious, irreplaceable, but no longer singular. This shift alters priorities. Economic growth is no longer constrained by planetary limits alone. Environmental policy gains a new dimension. Political power redistributes toward those who manage networks rather than territories. Civilization becomes less grounded, both literally and metaphorically. But this expansion also introduces fragility. The farther humanity stretches its supply chains, the more complex they become. Coordination replaces control. Trust replaces proximity. Failure in one place can ripple across vast distances. In such a system, resilience matters more than dominance. Asteroid mining, at its best, could encourage this mindset. Shared infrastructure, redundant pathways, mutual dependence. These are not ideals. They are practical necessities in space. At its worst, asteroid mining could harden competition, lock in advantages, normalize exclusion, Create an economy where access is power and power is inherited rather than earned. Both futures are plausible. The difference lies not in technology, but in governance and intent. Space does not force cooperation, but it rewards it. No single actor can sustain a complex space economy alone. Isolation is expensive. Interdependence is efficient. Over time, this reality may push humanity toward forms of collaboration that Earth-based politics has struggled to achieve. Or it may simply reproduce familiar hierarchies on a larger stage. Asteroid mining exposes a deeper truth about progress. Expanding outward does not automatically mean advancing forward. Distance does not erase history. It amplifies it. What humanity brings into space, its values, incentives, and blind spots, will shape what space becomes in return. And yet, there is reason for cautious optimism. For the first time, humanity has the opportunity to anticipate the consequences of expansion before it is irreversible. The ethical debates are happening early. The risks are known. The trade-offs are visible. That awareness alone sets this frontier apart from those that came before. Asteroids will continue to orbit the sun whether we reach them or not. Their resources will remain untouched if we choose restraint, or transformed if we choose ambition. The question is not whether asteroid mining will change humanity. It already has. The real question is whether humanity will change itself in the process. Because beyond the economics, beyond the technology, beyond the race for resources, asteroid mining marks a moment of choice. Not about what we can extract from space, but about what kind of civilization we intend to become as we leave our first home behind. When I started researching asteroid mining, I thought this story would be about technology and profit. But the deeper I went, the clearer it became that this is really a story about us. About how humanity reacts when limits disappear, and whether we know how to handle abundance without repeating old mistakes. Space doesn't change who we are. It reveals it. The same instincts that shaped our past are now reaching beyond Earth, carried by rockets and algorithms. Asteroid mining forces us to ask whether expansion is just another form of escape or a genuine opportunity to grow wiser as a civilization. The future won't be decided by the asteroids we reach, but by the values we bring with us when we do. This is where the light ends. Thank you for watching. And remember, some questions are meant to remain unanswered.